So as I said in my speech earlier, we need transformational solutions. And one of those, which I mentioned, was what's happening in China at the moment with sponge cities. And I'm so excited to be able to introduce you to Professor Kongjian, who is a landscape architect, urbanist, writer, and educator who actually invented the sponge city concept. So Professor Yu is joining us via Zoom from Beijing, from China. He's from the Peking's University College of Architecture and Landscape Architecture, and he actually founded this college. He is also the founder and principal designer of Tourinscape, and several of Kongjian Yu's core ideas for nature-based climate adaptations and ecological restoration, including the sponge city concept, have been adopted for nationwide implementation by the Chinese government and have global reach. These are the sorts of solutions I'd like to see happen here, are nationwide solutions that are really going to make a difference, that are really transformative. So I don't want to delay any longer, and hopefully the internet won't crash again, and we can hear Professor Yu joining from Beijing.
Hello, Roslyn. Thank you so much for such a wonderful introduction. So I will share my slides. These will be the slides. Yeah. Is it okay? Yeah. So we are all talking about climate change. Now, the idea of sponge city is a combination of Chinese local knowledge and the international thinking about how can we adapt this kind of flood, drought problems. We have huge challenges here, particularly in China. The monsoon climate, the influence of monsoon climate. Everywhere, $100 billion lost to the flood. But at the same time, people should understand, drought is even a more serious problem. So we cannot just drain away water. We have to keep water, actually. Global-wise, shortage of water is a fundamental issue. Conventional solution is great infrastructure. We're all familiar with. Accumulated risk, big reservoirs, that's a Hoover Dam, there's a Chinese Three Gorges Dam, and speed up the flow, channelizing the river, aqueduct flow from South China to North China to solve the problem of drought and fight against nature, of course, higher and stronger dams and dike system. Now, this may be necessary to some degree, solve some urgent individual problem, but it consumes huge amount of energy, destroys nature and its resiliency, and certainly lacks resilience at all. So this great infrastructure, we all know, fails, always fail. In US, the New Orleans is an example, and German example last year. China's Zhengzhou is another example last year that killed more than 300 people. So the alternative is nature-based solution. I will call it ecological infrastructure, which is critical for securing ecosystem services, woven together with great infrastructure. Now, I'm talking about infrastructure. It's not just a single mandate, there's a water problem, must be holistic. So firstly, we have to understand that this is a revolution thinking. We have to solve the problem differently. Philosophically, a city built on water-centered ecological infrastructure is called the sponge city because water is a key here. Its philosophy is to retain water, slow down water flow, and be adaptive to water. Totally opposite to the great infrastructure solution. There's a new book just come out by Eric Gears. She actually promotes the idea of a sponge city. Well, I really wanted to recommend for you to read about that. So she describes this as revolution. So it is totally opposite to the conventional or industrial revolutionary thinking about great infrastructure, we build of concrete and steels and so on. The secondly, the only way to reverse the dystopia trend is, I call dystopia because we use just too much concrete, too much steel, and create this problem, not just the flood, but also the atmosphere problem. To reverse this dystopia trend is to convince the decision maker to change the policy. Now, this is my effort in the past 25 years. I keep writing and lecturing to the top leadership in China and convince the government to adapt some of the nature-based idea, including this kind of huge mayor forum nationwide. I have given like 300 lectures to mayors nationwide, because Roslyn yesterday, a couple of days ago, asked me to talk about how to convince the local mayor. I mean, to convince the policy decision makers to change the policy. Now, this is a way I think it's quite successful to transform the policy process. I even wrote it to the Prime Minister, Minister Wen Jiabao, in 2006, which is about 10 years ago, to convince the national state to use the ecological solution to solve the multiple urban and regional problems that China are facing. So that's the second thing. Thirdly, we have to know that climate change is nothing new. Even we know that climate change is affecting global-wise, particularly in Europe and even in Australia and US. But for China, climate change is nothing new. We always have huge climate changes, the monsoon season. You know, we have huge flood, we have bad drought season. This we did 2008 about how the Chinese cities adapt to the flood in Yellow River Basin. We did about 100 cities and find that how they actually adapt and sustain for thousands of years. So sponge cities are inspired by the ancient wisdom of farming and water management that use very simple tools to transform the global surface at a vast scale in a sustainable way. Now, this is what I have to say, is that it's not so complicated. We have to understand by terracing, ponding, diagonal ponding, we can virtually create a resilient landscape that I call sponge. You know, at the source, you want to retain water. During the flow, you want to slow down water flow. At the sink, you have to be able to adapt to it. These are ancient techniques we've been used for survival for 2 or even longer time. So, but we cannot just use this kind of primitive nature-based solution, because we are now at a different stage. You know, we are all we have a larger scale problem now today. So the primitive nature-based solution needed to be distilled or needed to be upgraded to create a modular design and test it, use scientific understanding based on science, based on particularly ecological science, and upgrade those primitive nature-based solution, and so that they can be replicable and scalable ecological infrastructure engineering modules to apply at a vast scale. Now, this I just show you how this can be applied at a vast scale, use very simple technique, but use modern engineering way, an engineering solution to transform the infrastructure. And fourthly, the solution is beyond the city. Now we are talking about Pakistan, we're talking about Bangladesh, we're talking about China's Zhengzhou flood. Now those are happening at a regional scale, at a watershed scale. You know, it's not just a solution for the city. You should think about the watershed as a whole. So this is my solution I called source, flow, and sink. 3 stages. We need to transform at all 3 stages. Sponge catchment, sponge waterway, sponge farm, sponge pond, and even sponge lake and ocean. to need a landscape solution, transforming the services, the territory. And those must be very inexpensive to do that. Otherwise, it is a huge amount of money invested. Now here is we did this is a test for this model. This is Zhengzhou flood. Last year killed 300 people, as you said. And this site, the Mihe town or Sisui River Basin, is most severely damaged. And we are lucky to be invited for the post-disaster recovery of this area. So we use this example to show that this source, flow, and the sink strategy, how it can be applied, how it works, right? And the whole drainage area is about 370 square kilometers in size. Now we think about how can we transform the landscape. Now that must be productive because it can be always integrated with farming, okay? With a forest, with even orchard. Now that's so transform to retain water at the source. This curve will show you that even we have like 20 or 30% transformed to retain the water, you can virtually reduce the risk dramatically, or even have no risk at all. But certainly, if you have an extreme 100,000-year extreme rainfall, you need a combination of solutions. Now, this including the flow, the change of flow, and also including the adaptation strategies like raising the building or have some threshold, just raise the threshold of the building itself, only 1 meter or 2 meters, you can dramatically change the risk. So this is some of the result. I don't want to go to too much detail. We have a publication just a couple weeks ago. So over 20 years, we have tested and built over 500 projects in more than 200 cities in China. And I just want to quickly show you that this project, even a regional scale, can work to some degree. This is retention water at the source. Now this is a case in Hainan Island, the monsoon climate. Terracing, ponding, diking, islanding. This is right in the middle of the city of Sanya. We create about a 1 square kilometer size sponge. And certainly it's a whole integration of people's access, habitat recovery, and water inundation. That's rendering, and that's the process, how we do it. And it's only done in 1 year. Now, remember, in 1 year, that must be very simple, not so sophisticated. Now, this is the 30-year landscape you see. This is during the monsoon season. That's the monsoon season. That's during the monsoon season. And the people use it, recovered ecologically, bird habitat recovered. This is just a comparison between 5 years ago and today. You will see a huge banyan tree forest above the water is created. And when you see how it perform, that comparison is actually virtually solves the problem of urban inundation and also catalyst as urban development. So property value in this area quadrupled, 400 times as much increased in just 5 years. You can imagine. So economically, it is viable, and socially, certainly people love it. So we have another project in Yangtze River, Yangtze River middle reach of Yangtze River area. This is in Nanchang City. Certainly suffering climate problem, flood, and also in the city we have this garbage dump or coal ash dump. Now we want to transform that into a sponge. The solution certainly is a sink solution, which means adapt to the flood. We create islands. Now these islands are only 2 meters above the water, so that they create a forest during the above the water. During the monsoon season, it can be flooded. And during the dry season, you will see the islands appear and they become a park. Now, this is this just also built in 2 years. Now, this is during the dry season, people use it. This is a flood season, and the people use this space in the middle of the city. Now, that's about 50 hectares in size. So it can solve the problem of about 1 million cubic meter of water, solves the urban inundation in this area. At a smaller scale, even in North China's Tianjin city, we create this sponge in 2008. It solves the urban inundation about 10 times as much of this area. That's a ponding system, become a park, resilient landscape, beautiful recovered habitat. This stormwater maintenance. And by the way, at the same time, it solves the problem of soil contamination, and it covers biodiversity. You see here how biodiversity increased dramatically. So finally, go to the flow. Okay, here is how can we change the flow and solve the problem of urban inundation? I mean, the regional flood by certain degree. This is the case in Zhejiang's Jinhua city. We actually move the concrete and increase the mining. We call this the reduce the flow, right? Reduce the flow, mining rate. This is we transform and terracing the riverbank and allows the park to be floodable. That's a 100-year flood occurrence. Now this 20-year flood, and this riverbank become transformed from concrete riverbank all the way to a green infrastructure. These are even earlier. 20 years ago, we did this case in Zhejiang province at the coastal area, which is suffering monsoon flood. And we remove concrete, again, create this green nature-based solution. And there's a test to show that for over 20 years, this is safe and also sustainable, and the people love it, and it have multiple ecosystem services. Now, it's just a fairly simple common sense to some degree. Certainly, you certainly have scientific understanding. This is a biological, this is the GIS, geographical information analyze how flood will happen. That's 20-year flood, 10-year flood, 20-year flood, and 50-year flood. So flood doesn't go anywhere. You have to understand that very subtle change of topography will reduce the risk of flood. I want to just show you another big example how this can be executed systematically. This is a city in West China, Liupanshui city, channelized the river, as you can see, rainfall, polluted wetland. So a holistic system, transforming the whole landscape into sponge city, green infrastructure, even all the way to the community garden. That's a process of construction, terracing, ponding, diking system, transforms this kind of river system into this river. That's slow down the process. Now, that's the result. Now we can see that's a test. That's the data shows that at least it can reduce the peak flow and also delays the peak flow by 1 hour. That's a very fundamental change for this kind of transformation. So we are talking about transformation of the whole infrastructure. Now, from the great infrastructure we are so proud of, this industrial civilization to the green infrastructure, we are trying to do it. The ecological infrastructure, so for the ecological civilization, removes concrete, terracing the riverbank, and spongelize the river, right? So, and it have multiple ecosystem services. Now, at the end, when water too much at the end, as a lake, as the ocean, or near the city, you cannot just protect it. You do flood wall like that, but we can have a better way, or we can have at least an alternative to support the conventional solution. So it's a resiliency. So we remove higher and higher flood wall in Sanya like that, and terracing the riverbank and create a spongy and resilient ocean coastal line here. But that's the ocean here. You see Sanya. This was suffering the ocean surge during the monsoon season. Now this you will see today, and it's already went through a huge flood last year, and so it has been tested successful. Even we don't have data yet for this case, but certainly the experiment shows that it is successful. Right? And this is even larger scale in North China's coastline here in Qinhuangdao. We spongelize it, create a porous landscape, create a buffer zone between the ocean and the land that function as a buffer, at the same time filtrate the pollution from the urban and agricultural runoff. So more than ever, we have to rethink the way we build our cities and the way we treat water and nature, and even the way we define civilization. Now, the risk, always, when you look at the history, how flood damaged the city, you will see that in many cases, or in often the case, that it is because of fail of the infrastructure we did. So sponge city or sponge planet, I will say it is a planet scale solution, is a holistic and nature-based solution to protect and restore ecological infrastructure and make wise use of nature's services. Now, those services are free, in combination of production, habitat recovery, cultural services, and also other services together for the benefit of the planet and the welfare of the people. So we have the global vision already, right? We do have to think like a king. The big vision, how to mitigate the climate change, how to adapt to climate change. But we really need to do is actually down to earth transformation of the earth, of the globe. Now that's a peasantry, that's a peasant approach who transform the globe down to earth. Simple, just by cut and fill, that may work very well. That's what I'm talking. Okay, thank you, Roslyn.
Thank you very much. That was fantastic. And I'm sure there'll be a lot of interest and questions in your talk. I'm not sure, you probably can't see us, but we haven't got time for questions? We have got time for questions. We haven't got time for questions.
3 minutes.
We've got 2 minutes for three minutes for questions. So does anyone in the audience have any questions at all to Kongjian? It's your big opportunity because we don't get to see him very much. So he's achieved an amazing amount in China. You know, it would be fantastic if we could have that scale of change happen here. But if anyone has any kinds of questions for him in the audience, that'd be great while I'm waiting for the questions to appear on my screen. There's supposed to be ones on this screen, but there aren't any yet. Oh, and soon I'm going to have to. Sorry, there is a question up here. Oh, there's a question about whether you've worked with any Australian cities.
Well,
you're muted.
What?
Can't hear. So, you're muted. Oh, you're not muted.
So what's the question?
That's good. Have you worked with any Australian cities?
I visited many of Australian cities, but I have no projects there yet. I believe that it's not so complicated. I trust. I know many good landscape architects in Australia also. They know how to do is stormwater. You have this sustainable water management solution. It maybe just have to upgrade so to the larger scale, the soft to landscape to replace some of the engineering work that may work at a regional scale.
So I have some more questions here. How has the sponges approach worked in areas that are also regularly subject to droughts?
As I said, sponge city is not just a solution for flood. It is a solution for drought. Monsoon climate in China, we only have 3 months of monsoon climate, 3 months. And we have 9 months for as a dry season. So sponge city, it is a regulation solution to keep the water during the monsoon season and let it recycled and used during the dry season. So it's a holistic solution. Yeah.
Thank you. I love that. So we have a question here about lots of questions here, actually. What should be the first step if you want to adapt this paradigm for existing cities in Australia, established cities? What's the first thing you have to do in an existing?
Well, the first thing, as I mentioned, the first thing is changes the mentality of, and we need the decision-making change. We need to change the code system. Now, the engineer dominating the civil engineering solutions, they believe that the concrete, the pipe systems, the dike system can solve the problem. As I will say that they will fail. So we have to have mental change. We have the fundamental changes. It's a revolutionary change about how we trust, civilization. What do we define civilization?
And there's a question here about for large established cities, how do you get around the argument there's not enough room to create a sponge city where water spreads across the landscapes from Juliet Meyer?
Yeah. Yes, as I said, the problem, we have to talk about regional flood and urban inundation. So if you just change the urban inundation, it's easy. Imagine every family can collect water, right? Every roof can collect water. So if like 30% or 50% of empty green space, roof garden, or even your community garden can be a sponge, you virtually have no problem of urban inundation. You even don't need a drainage system, drainage pipe system, right? So that's one issue. The second issue, we have to go beyond the city. As I said, the city is part of the region's drainage system. That's why you actually have to go talk to the agricultural system, the farming system, and certainly the mountainous area. That's why in China, because in China we have a long time of agriculture. So any piece of land being cultivated. Now that's why Sponge City is actually part of the agricultural solution to regulate water as an irrigation system. And that's what my answer. Yeah.
So I have an interesting question here from Wendy Gambley about how do you control mosquito breeding?
Yes, remember, mosquito always happen when the ecosystem is not healthy, like dirty water, like no life, no frogs, no dragonflies, yeah. So that's why we need to create a healthy ecosystem. We need a frog, we need dragonflies, and so on. Yeah, like my own home, I have a sponge in my living room. I keep a fish, and the fish actually eats the larva of the mosquito.
Oh, there you go. Okay, so here's a question. Is it challenging to find appropriate plant species that can tolerate both droughts and floods?
Yes, I will say yes, but you remember the nature has this wisdom. I use the sequoia, we have the banyan trees in the south, we have cypress in Everglades, and in your country you have mangrove. So nature has the solution, right? Just look into nature, how the species will tell you. Yeah.
All right. Well, thank you very much. Unfortunately, we've run out of time. I'm very disappointed, but I'm being given my instructions. So I'd like to thank you very much. If the audience can just thank Professor very much.
Thank you so much. Yeah.
And I think we'll have to meet with you again. Oh, he's gone, has he? Okay. Sorry. Oh,
Okay.
he's back. Okay, so we'll have to meet with you again for a longer time. I have a lot more really interesting questions here for you. I'll see if we can save them and I'll send them to you and you can give me some answers. So thank you so much, and hopefully we'll see you again soon.
Thank you.
Oh, you're welcome to stay if you'd like.
Thank you. Yeah.
Okay.